Hey, and welcome back. Professor Hendricks here. And now I'd like to talk about strings. Among the 5 different data types that we talked about last time, strings are perhaps the most nuanced and have the most details that I think we should discuss. First off, I'll enter the Python terminal by typing in Python. And the way I define a string might be something just like DNA equals ACG, some random series of ACGs, Gs, and Ts. Now, the unique thing about strings is that they have an index. So this is a series of characters, and each of these characters has a number associated with it called an index. And the index begins counting at 0 and goes up to the length of the string minus 1. So in this case, if I say DNA bracket of 0, that refers to the first character, that's G. And then similarly, 1 will refer to the C, and 2 will refer to the next G, and so on. So the last index, therefore, is the length minus 1. You can actually compute the length with the len function, and this is a function as opposed to a method associated with a string object because len is applicable to other data types and more complex data types such as lists and tuples that we'll learn about later on. So therefore, DNA of len of DNA minus 1 refers to that last G. Also, interestingly, and this will become important later on, -1 and negative indices will access from the end moving backwards. So in other words, the index of -1 actually refers to this G, and this C would be an index of -2. So in other words, -1 gives the G, and -2 gives that C, and then -3 should be the A, and so on. Okay, now let me clear my screen and go back to that definition of the DNA. Now another key thing that we may want to do is access a substring. A substring requires defining a start position and an end position. So let's say I wanted to start with this first particular A nucleotide here and go up to the next A. So the first A has an index of 0, 1, 2, 3, confirming it with the 3. No problem. So the way we indicate a substring is using a colon. So we want to go 3 up to, so 3, 4, 5, 6. The index of this A is 6. However, in Python, we want to go one more than the last index that we want because the end position as defined by this colon syntax is not included in the resulting substring. So therefore, we want to use 7 to get that A. And if we actually reduce it down to a 6, we would only get 3 characters. So in other words, the substrings go up to, but not including the predefined end position. Now you don't always want to hard code values like this 3 and this 6. You might also want to define int variables start and an int variable end such that the DNA sequence can be accessed from these defined int variables as well. And this is kind of the way you want to start thinking about this if you want to programmatically implement this and access strings from start and end positions defined either from user input or from some input file. Next thing that we may want to consider is a step size. We may want to access substrings that might access every other character. If you consider the genetic code uses a 3 nucleotide pattern or triplet code, we may want to, in some instances, access every 3rd character. So the way we do that is by specifying a step size. So for example, a step size of 2, we might be able to do something like start and step, and that will give us every other character. So in other words, this first A, and then the T, and then that will be it. If we want to go further and say A, T, G, T, stopping at this T, we would need to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the ninth index, and we would want to specify our end position to be greater than 9, so I'm going to specify 10, so that it will go up to, and also make sure that it includes that last T at an index of 9, so our end position needs to be 1 more than that. This is how we would define substrings, but what about decreasing positions, or decreasing indices? So let's say I wanted to access a substring starting at this A and then decreasing down to this first A. So the last A here, or this second A here, would be at index 0, 1, 2, 3, 4, 5, 6. So therefore my subsequence, I want to start it at 6. So the start is always included regardless of whether it's increasing or decreasing. So we'll start with 6 and then we'll go down to, the first A here has an index of 3. So if we want to include that A in our substring, we'll need to go all the way down to the index of 2, one more than the desired final character's index. And we have to specify our step size, and in this case, if we want a decreasing sequence, our step size needs to be negative. So therefore, as you can see, going in decreasing order, A, T, C, A, and this is the substring that we got, A, T, C, A. If we want to access the entire subsequence in reverse, we need to specify a negative step size, but also we need to do something like this. And what's interesting is that, as it turns out, you can't specify an end position explicitly. I can specify a start position explicitly, and there's a couple different ways to do that. I could do, since we're starting at the end, I'm starting at the -1 position, as I said, that refers to the end. So that would work. Also, as I said, the length -1 refers to the end, so this would also work. Remove that extra minus sign. So that also works. And I can use what is known as the default option for the start position, which will also give the entire sequence. Let me explain what's going on here. By the default position, it's essentially always trying to include as much of the sequence as possible that's consistent with the other parameters that are specified. In other words, if I specify DNA of colon, that will be the entire thing. If I specify DNA of 4 colon, it will be the subsequence starting at index of 4 and going all the way to the end. Similarly, if I were to specify colon 4, that would be the DNA sequence starting at the beginning and going up to, but not including the 4, because again, the end position is not included when specified explicitly. And so therefore, going back to this idea of explicitly specifying for the reverse substring, if I wanted to specify the end as 0, well, that wouldn't work. It's dropping off this last G that was being printed out here, because by specifying 0 as the end, it's trying to go down to, but not including that 0, so it's excluding the 0th index. But then you may say, well, let's go -1. Well, that gives the empty string, because in this instance, the start and the end position as indices both refer to the same position of the sequence, the last character. So therefore, it's going from the last character to the last character in decreasing order, so that's just nothing. So therefore, the only way to specify the entire sequence in reverse is to not specify an end position and to use the default option, meaning include as much of the sequence as possible. And so there you have it. That's the sequence in reverse. And then similarly, I can leave off the start position because I want the entire thing in reverse. And for biochemists out there and molecular biologists, this of course is not the reverse complement. We'll need to do something else to get the complementary sequence and reverse that. So that's something that we'll have to figure out next. And until then, I'm Professor Hendricks, and I'll see you next time.